do things like this. It's great fun. You're right.
Hi. Right. So, hi. This is interesting. So,
we're not live.
Now we are live. We are not live now. We are live now. We are live now.
Okay.
Apparently.
Third time lucky.
Third time is a charm. Hi everyone. You were watching Test Containers Live, and it's my great pleasure to see that we're back at the end of the summer. It's a very exciting day, and we have a very exciting episode here. Our guest today in the studio is Grace Jansen, the one and only. How are you doing, Grace?
I'm great, thanks. Thanks so much for having me on the show.
Excellent. So Grace needs no introduction, but let me quickly just say a couple of words. She's the developer advocate at IBM working on Open Liberty, MicroProfile, and other cloud technologies. And before getting into tech, you studied biology.
Yeah.
Which is very interesting and brings a very unique perspective on different projects. And you also have a book on reactive systems.
Yes, yeah, I did. It was very fun to write, very different.
Right. Interesting. Okay, so I know that you, as a developer advocate, you do a lot of education, writing guides and tutorials, working with sample applications, and kind of sort of passing the knowledge about the modern best practices and how people should be doing software development into masses. There is a variety of topics that you are interested in: reactive, cloud native, transactions, stateful things. What are we going to talk about today?
So today, I really wanted to delve into a concept called the 15-factor app methodology. You've probably come across the 12-factor app methodology. Yeah, it's been around for a decade or so. Delving into the 15-factor, which is sort of a step further, as the name would suggest.
Right. So 12-factor apps were sort of a description of what a cloud native app should look like or could look like. Does it need to? What qualities does it need to have? What do you need to think about when you're starting a project that you want to call cloud native, instead of just lifting your full-blown IBM WebSphere into a cloud instance, which also a reasonable maybe thing to do at some point of time, but cloud native was thing. And now you are expanding that to add new things that we learned in the recent years.
Yes, exactly. There are still aspects of the 12 factors that are important and that we need to be thinking about when we're designing cloud native apps. But it was written a while ago and there weren't really many updates to it. So yeah, this update, which is published online, is really about adding in things that we've realized are actually pretty important when it comes to creating cloud native apps now.
Right. Can I ask for a quick spoiler? Is testing a part of 12 factors or the 15s?
Both. Spoiler alert.
Excellent. Yeah. Right. Okay. Let's dive into the 15 factors apps, and then I know that you wanted to show a few things, and then we'll take it from there.
Fab. Great. So yeah, let me delve into these 15 factors a bit deeper and see where testing comes into it, firstly, like Oleg gave away, and also what those additional factors are and why they were added. So the 15-factor app, really, first thing I'm going to do is kind of introduce the 12 factors, just in case anyone on here watching hasn't come across them before. I just want to make sure we're on the same playing field here, and then go on to the 15 factors. So if you've not come across the 12 factors before, definitely head on over to 12factor.net. Really great website that kind of goes through each of the original 12 factors, and explains why we introduced them in the first place, and what they're useful for. Now, the original 12 factors, giving the game away a bit with this, so if you don't want to head to the website, that's fine. I've put them here. So these were the original factors that were introduced. They were originally defined by the developers over at Heroku. And as Oleg's kind of said, this was really around behaviors and characteristics of our applications that we wanted if we were going to make them really cloud native and make full use of that cloud infrastructure. So a lot of these you probably do naturally anyway, like, for example, code base. That's all about, you should have a single code base for your application, but you might have, for example, many applications of that particular code base. Things like having external configuration, having, for example, backing services, so all your resources attached as backing services. And you'll notice in there something called dev-prod parity, which we'll kind of come on to in a little bit. Spoiler alert, that's where the testing comes in. So that was then sort of the 12 factors. And if you want more information on this, I've also written an article that you can check out that goes into this in a lot more detail and also links off to some labs that link to technologies for each of these. So if you want to check out those and do some of the labs for, I don't know, if one of the factors piqued your interest, then check out this article because it'll help you with that. So now going one step further, we now have the 15-factor app methodology. And the reason that this sort of evolution occurred is really because our underlying infrastructure in the cloud has moved on. Not only that, but our methodology in designing and building applications and our experience of distributed microservice-based applications has changed as well. We've learned, we've evolved. And so we need to reflect that back in our methodology. And also, there are some surprising things that were left out of the 12 factors. So I won't make you guess which ones are added. I have highlighted them here just to make it a bit easier. So the ones in yellow are the new factors, and the one in green is the one I want to talk about specifically for testing. So the new factors we're going to go through in a bit more detail and look at what technologies we can actually look at. One thing I did want to point out that I was surprised at is the addition of authentication and authorization. There was literally no mention of security in the original 12 factors, which I was pretty surprised at. You know, it didn't necessarily register when I first looked at the factors, but seeing the revised 15 factors, it makes complete sense that we'd want to be considering security in a cloud native world. So I've also written a sort of, again, brief article which links off to guides. So if any of these we don't get round to looking at, so the additional 3 factors, for example, if you want to look at technologies and get hands-on with technologies that relate to them, then check out this article. It links off to the individual labs that you can try. And actually applying this to sort of applications, this is sort of a generic sort of application flow. So we've got an arrow, which is sort of loosely representing our delivery pipeline. We've got our cloud, whether that's public or private or mixed. And we've got things like repositories that we're going to pull artifacts down from or publish artifacts to. And we can start to map out where the 15-factor app methodology comes into play, sort of the various different elements of app design and development that it affects. And we can actually start to see that from introducing these 15 factors, we can start to gain really important behaviors and characteristics that are often associated or that we want to achieve if we're really going to thrive on the cloud and not just sort of barely survive on the cloud. And these are factors that have come from the various definitions of cloud native from vendors, organizations, foundations, etc., that we pulled out from those sort of characteristics and definitions. And we can use various different tools to be able to achieve that. And we're going to delve into some of those tools now. So the one particular factor I wanted to point out that's been pulled over from the 12 factors, obviously there are 11 others, but I'm just going to focus on this one for this particular topic, is environmental parity. Now, you might notice that actually the name has slightly changed. A lot of the original factors' names were slightly tweaked between the 12 factors and the 15 factors. So in the 12 factors, this was actually called dev-prod parity. It's been expanded because as developers, we don't just have development and production. We also have things like testing, QA. So we need to have parity between all those environments, not just development and production, which is why that name change was made. So what do I mean by environmental parity? Really, this is all about ensuring that the environments that we're creating, whether that's for development, testing, production, etc., that they are as similar as possible. Because sometimes what you can have is, while some organizations have done more evolving, a lot of organizations actually have an environment where the shared development environment might have a different scaling and reliability profile than testing, for example, which might also be different to production. You might be using different database drivers in your dev versus production. Security rules, firewalls, and other environmental config might also be different. And all of these things contribute to potentially having different issues in each of those environments. So you might end up having an application that's absolutely fine in your development and testing environment, but doesn't work or has errors or issues in production because those environments aren't the same and you're using different tools in them. So this is all about really keeping this as similar as possible to lower the risk of unexpected errors and to support that greater reliability and continuous deployment and development cycle. So how do we actually achieve this factor? This is where technologies can really help. For example, using the same backing services for all of your deployments, really ensuring that you have that solid continuous integration pipeline, and that you're deploying to production as often as possible. These are kind of behavioral elements, but also utilizing tools, for example, like container tools like Docker, can really help to make those sort of production-like environments much more accessible to developers on their workstations. And that's where we can use tools, for example, like test containers or even microshed testing to be able to mimic that production environment as closely as possible for our testing environment, which is where we can keep that parity, that similarity between those various environments and really follow this factor as suggested by this methodology. So I'll come back to that in a minute, but I just wanted to highlight it given the context of this entire podcast. But that's the one that's been pulled over from the 12 factor I wanted to cover. But then there's also additional factors. So this is probably where a lot of people may not know these additional factors and might be interested in finding out more. So the first factor that was added is API first. So it's important to sort of bear in mind that not all of the factors in this methodology are necessarily specific physical requirements imposed by the cloud. Some are more to do with like habits of people or organizations that are actually building those cloud native apps. So this is one of those factors. This factor is all about really sort of putting the API first in terms of making it formally recognized as a first-class artifact in your development process. It's all about sort of giving teams the ability to work against each other's public contracts without having to interfere with the internal development process or what's inside their particular microservices. So really, when you're building cloud-native applications, what you're building is a microservice with an API that something else is probably going to call, and you're going to call someone else's. So if it's not clear what your service offers or how to utilize the API within your service, how are people going to be able to understand that without then delving into your code, interfering in the internal development process? So this API is all about making it really clear as to what the API is going to be for your microservice, how people are going to make use of it, ensuring that you're actually thinking about that right back at the design phase, not just in development. And by doing this, by really putting the API first in your design and development, it enables you to test and to vet your direction and your plans before investing too much into supporting a given API. It gives you greater flexibility in terms of changing that, depending on what your users want and your stakeholders need. And it enables sort of greater collaboration with your stakeholders. So designing what they need from each API or service and being able to sort of mock those up before, as I said, before putting too much energy and effort into actually supporting it. So how can we achieve this one? Well, the first thing that we need to do is really be participants. This is an ecosystem. We are in an ecosystem of shared microservices, shared services. And so we need to be participants in that by really enabling us to share a very clear and concise public contract for our microservices. And we can utilize tools and frameworks and specifications like OpenAPI or API Blueprint. They're open source specifications. And we can use tools to be able to implement those open specifications like MicroProfile OpenAPI, which we have a lab on if you want to try that out. There's also obviously alternatives if you want a proprietary solution like Apiary or IBM's API Connect tools, but there's also lots of open source that you can make use of too. So that's the first additional factor. The second is telemetry. And you might be thinking, for those of you who know the 12 factors, you'll know that originally in the 12 factors, we had something called logs. So you're thinking, oh, but I've already got logs in there, so why do I need a separate factor for telemetry? Well, logs are a really great start, but generally it's a tool that you use during development to diagnose errors and code flows. Logging really is typically orientated around the internal structure of your app rather than reflecting real-world customer usage. So basically logging, in summary, logging is how you collect data about your app in the lab, but when we're actually wanting to collect our app when it's released into the wild, we want to collect information there as well. And that's where we're going to use telemetry. So this wasn't actually among the original 12 factors. This is all about being able to sort of track and understand how our application is behaving when we release it into the wild west of cloud native. So we can do this in various different ways. There's lots of different data that we can collect for this. It might be that we're collecting application performance monitoring. So like how many HTTP processes are we doing per second? It might be domain specific telemetry. So how many products were sold via the iPad in the last 20 minutes? Or it might be like health and system logs, which is quite common. So system health check information, or even event information like start, stop, scale, etc. So this is really a reflection, this edition, of the fact that our applications are more complex. As our infrastructure's evolved, as our applications have evolved, it's become more complex. And so we need to be able to track that so we can prevent potential failures and bottlenecks and really make sure that our application is working as we intended it to. So how do we achieve this? Well, again, there's lots of different open source that you can make use of. The first thing is we need to collect that data. So we can use APIs, for example, like MicroProfile Metrics and MicroProfile Health. These can help to provide important information about your apps and your microservices when they're running in the cloud. And if you want a really easy way to consume that information, we ideally want to be using things like dashboards. So you can make use of stuff like Grafana to be able to visually analyze that information as it comes in real time. So that's telemetry. And the last one is authentication and authorization. Like I said at the beginning, I was really surprised that security was not part of the original 12 factors. So for me, this was a very important addition. And I think, it doesn't need to be stressed given the events that have occurred recently around like Log4j, etc. We're all aware of the importance of security, especially in cloud native applications where, any number of people could be accessing your application, your data, etc. So really, this is about two steps: making sure that your users are authorized, and then making sure that they have that they are authenticized as well. So are they who they say they are, and are we going to give them access to this particular service within our application? So this is really about adding those additional security elements through authentication and authorization to cloud native applications to increase security. So how do we do this? Well, in an ideal world, all our cloud native applications would really secure their endpoints with RBAC. So RBAC stands for role-based access control. And really what it means is we're assigning roles to particular users, which gives them a certain level of authorization to access particular services. What we don't really want to be doing is giving superhero powers to everyone who wants to access our application, because then it would be useless. We want to be able to be assigning them what they need based on what they need. So we don't want to be babying them, but also we don't want to turn them into superheroes. There's a nice in-between in the middle there, and you can have multiple roles as you go up that scale. So the way that we can do this is we can make use of things like tools like OpenID Connect, OAuth 2, Keycloak. You can also make use of things like MicroProfile, which has an API called JWT. That stands for JSON Web Token, which allows you to store session information about the users that are accessing your application. Again, allowing you to add in that element of security for each of your endpoints. So that is the last additional factor that was added. So hopefully what I've shown is really that, the 12-factor apps are a great place to start. They have some really great characteristics and behaviors and elements of application development that we do need to consider when it comes to building effective cloud native apps. But although they're a great start, in order to actually thrive in the cloud, infrastructure and application methodologies and architecture has moved on, and we need to too. So we need to be evolving these factors as we evolve those elements as well. And so that's where these additional 3 factors can really be beneficial. And I'm afraid to say there are absolutely no excuses, because I've just listed a ton of open source. So all of you should be able to actually go ahead and try some of this for your own applications. And yeah, hopefully you can take an action away of maybe just evaluating your own applications against these 15 factors, including the original 12, and maybe consider what you could do to try and improve your applications through them to really, truly thrive in the cloud. So thanks for listening. I've got some resources if you want to take a look. A lot of them I've already put in to the PowerPoint. But yeah, hopefully you guys have learned something from that.
Yeah, absolutely. I think this was a very nice, quick rundown of the evolution. I cannot imagine how the original 12-factor didn't have security.
I know, right?
That is interesting, but it also shows, I think, that how out of hand the cloud thing got.
Yep.
Right. Because the original 12-factor apps, and this is a general sentiment, right? The way we did things before wasn't bad because we were like less experienced or silly, right? It was just how we thought like it's great to do things back at the time. Yep. Right. So it's,
and I'm sure in like 15 years time there'll be another factor that we'll look back on and go, oh my god, how was that not included?
Yeah, we'll be like,
we're always learning. Yeah,
back to logs. Right? And literally, and that is also like sort of the telemetry, right? What you mentioned, telemetry, and you talked how logs are not enough. What's often is highlighted in the sessions about telemetry is that it consists of three things. It's logs, metrics, and traces, right? So performance data, various metrics, and logs. And how back then we mostly thought that, yeah, sure, logs are fine. It's just if something goes wrong, you just go in the logs and grab them and see what the problem is.
Yep.
And now you have literally cloud services that the whole point of existing is to gather and collect logs, which is fascinating. So very, very good. Thank you for the rundown. Good resources. I personally, of course, am the most interested in the environmental parity, which is, I liked very much that you had so on the slide, if you don't remember, there were three things. There was dev, there was prod, and there was QA.
Yep.
Right. And normally there are two parities there. One is dev and QA, and the other is QA and prod, because, and they sort of together align into this. Like, oh, we could be using similar technologies across all three, because we can use QA, or if we talk about developer first approaches, right? Then QA would be your continuous integration pipelines, right? Git. That's what I thought. Very, very, very aligned with the DevOps movement as well, where there is dev and there is the circle for ops, and there is one arrow in that page that is like test. But it is there.
It just highlights the importance of it, though, right?
Like, yes. It's a small arrow, but
it's important.
Right. So do you have an example of a 15-factor app somewhere that we can maybe
I do.
Look at and maybe run a few tests and look at the technologies that are sort of adjacent?
It's almost like we prepared this beforehand. If you go to the last link on that slide, that is the Liberty Deep Dive. That's the link to GitHub. But we do also have it on our website. So let me switch over what you're looking at. I'll just hide that for a second. So we have a blog all about it. So basically, we wanted to really create an application that you could go through step by step, that took you through a lot of the different behaviors and characteristics that are considered in those factors. So it goes through a bunch of different stuff. I mean, you can see the stuff that you'll learn here, bullet pointed out. So it includes things like telemetry that we were just talking about, but it also goes back to sort of the more, I would say, more basic of the 12 factors, things like having external configuration, making sure that you're persisting data correctly. And also we've included things like security by using things like MicroProfile JWT. But importantly, we also do tests for this application in a cloud native manner that really helps to keep that parity between environments. And we do use test containers for that. So if you want to have a go with this yourself, you are more than welcome to. You can run it locally if you want, or in whatever cloud that you perhaps prefer. It's all just using open source software, so it should be fairly easy for you guys to use. If you don't want to worry about local setup and prerequisites, you can try it on our cloud hosted environment. Or, as I say, you can complete it on your own laptop if you've got like Docker Desktop, for example, or any other cloud. You might have the Test Containers cloud. So when you click on it, you'll be taken through. You can either do the cloud hosted one or run the lab locally. I would normally show you on the cloud hosted environment, which you can access through this link. Yeah, it's logged me out. You'll need to log in, and then it will ask you, like, are you a robot? Because we had issues with Bitcoin miners.
Yeah. This is authentication.
Yeah, exactly. So I've already logged in via GitHub, but it will ask you to log in.
This is the other one, right? This is authorization.
Exactly. Security is needed.
Doesn't ask you who you are, but it checks whether you're human enough to consume cloud resources. I
have to admit, I have already logged in, so it did ask me who I was, I promise. I've logged in via GitHub. So there's loads of different social logins you can use.
So while we look at this fascinating spinner, it's all about the processes, approaches, and technology. So it's not something that you can do. 15-factor apps is not something that you can do only with Open Liberty or MicroProfile, right?
No.
This is something that, like, the approach how you build applications, and you can do that with any other framework on any other.
That's the nice thing about it, is it's technology and language agnostic. That's why I love this methodology. Because a lot of the others will specify, like, oh, you need to use this framework, or you need to use like Java or Go, or it will be very specific. Whereas this is language agnostic, technology agnostic, platform agnostic. So it's really completely up to you as to which technology or platform or like tools you want to use. These are very generic behaviors. So it's up to you as to how you implement that with particular APIs or features.
Right.
Yeah.
Right. Let's look at the example of a Node.js application here.
So what we got here is, this is normally our cloud hosted environment. I did not pray to the demo gods enough today. And so my containers are essentially not running correctly in our cloud hosted environment. So instead, what I've done is essentially just done it locally instead. So but if you do want to go through this, it is really easy once we get it fixed, which will hopefully be in the next few days. And essentially, there's instructions on the left-hand side. You've got an IDE in the right and a terminal. If you don't already have a terminal up here, so if I close these, you can just do terminal, new terminal, and it will open a new one up for you. You can use the Explorer view to check out your directory structure and to be able to open files if you need to. But the nice thing is we tried to make it as easy as possible by giving you the commands that you can just literally click a button and they'll execute. So you can either copy and paste them manually by using this sort of 2-file thing. So copy, and then you can paste into your terminal, or you can alternatively just click this execute button and that will do it for you. So it makes it really easy for you to be able to use this fairly quickly and sort of go through each of the instructions. And then there's explanations as well as to like why we're doing certain things in the code, which should hopefully give you a better understanding of why we've added that in instead of just throwing a bunch of code at you and not really explaining. So yeah, what we've done in this is, if I skip to here.
I just want to emphasize the amount of thought that went into this environment, right? Just imagine that the target audience is developers. You would assume that developers would not have problems copy and pasting code. That's what we literally do for a living. But there is a single button that does both actions for you. This is the automation I live for.
Exactly. This is the ease that we want in everything.
Yes, this is the developer experience that is so emphasized in all modern products. No, but all jokes aside, I think this is a great environment to try different things, and kudos to the team who figured it out.
Thanks. And yeah, it's the same environment for all our guides. So as I mentioned, those articles that I was pointing to take you to some of the individual guides that look at those specific technologies and those specific factors. And it's the same environment for all of these. So if you see a running cloud option on them, then you can click them and use this cloud environment. I think it was mainly a problem with the Open Liberty operator that we had today. So most of the guides are not affected. It just so happens that our deep dive uses that. So that's why I can use that today. So you should be able to do a lot of the individual guides without any issues using that environment.
Right. So to alleviate the problem, what Grace has prepared, and I know that because she told me that beforehand, is the VM, is the cloud VM that is sort of similar to this cloud IDE VM, but it's just a local VM that runs locally.
Yeah, exactly. Which really just highlights how like all of this can run wherever you want it to.
Right.
You know, we're just running on containers, so spin it up wherever you want it.
Yeah, and right. So let's talk about what is this application. Can you give us a little bit of intro what it does? I know that it's a sample app, so it's kind of limited in the
it's not meant to be complex. You know, if it was complex, it would be even harder to understand the technologies. So we tried to make it as simple as possible to really ensure that you're learning the technologies and not trying to learn the app. So this app is the same app that we use for all of our guides. So again, if you're doing multiple guides, it should be really easy because it's the same app again and again. So it's really made up of two main microservices. You've got the inventory microservice and the system microservice. And essentially what we're doing is the system microservice every 15 seconds is essentially getting information about your system properties. And then the inventory microservice is calling the system microservice and it's storing a list of the most recent version of those system properties. And that obviously changes over time. And then what we can do is essentially do REST requests into our inventory microservice to be able to access that list. So if you've got multiple systems running, you might see multiple systems, whereas most of the time we've just got one in these demo applications. So we'll just see that single system change over time.
Right. So sort of we can say like what Java is installed.
Yeah, exactly. Yeah. Or how many, I don't know, like threads are you using currently? Like,
okay. Yeah. So it's a small kind of sort of monitoring system.
Exactly.
And it stores data in the Postgres.
Yes. Yeah. So in this particular version, because we wanted to show linking to databases in this particular tutorial, we have included a PostgreSQL database, but for the other labs and the other guides, they don't always have that. Sometimes we introduce Kafka. So in some of the reactive guides, we've got a Kafka sort of broker in there instead. So yeah, if you're interested in seeing different ways of creating and designing applications, check out the other guides. Yeah.
Cool.
But yeah, right. So essentially in this, we've included this one, test containers. So essentially what we're doing here is adding in tests to be able to run them in a container to make those environments as similar as possible. And that's essentially, again, why we've added in this database to really show that if you've got backing services, you should really be running your tests in an environment that includes those backing services so that it's as similar as possible to your production environment rather than just running your microservice and seeing if it works. Because really, this is all about integration testing, and you need to be testing the integrations with those backing services as well.
Right. I absolutely agree, obviously.
Obviously.
Right? I applaud your technological choices. But this is a correct sentiment, right? We want to run our tests in the environment that is similar to what we run in production, at least to the point that if we are using Postgres in production, we would love to use Postgres for testing instead of like sort of doubles that might or might not be fully compatible.
Exactly. Yeah.
Right.
So that's what we tried to achieve here with the test containers. And essentially what we have is we've got a few different classes that we specifically get you to edit as part of this tutorial. So I've actually got if you don't want to do it in the cloud hosted environment, there's also a local version that you can access, and that's what I've got up here. And so this actually shows you what the class should look like for the one that we're actually editing. So the one that has our tests inside it is actually this system resource it.java class. And that's where you'll see a lot of the acronyms that you might recognize from frameworks like test containers. So we're utilizing things like the @container annotation and the @test annotation. In fact, we're actually integrating this with JUnit 5, which I know Oleg has been looking into recently.
Yeah. Can you zoom in a little bit?
Yeah.
Because my eyes are not what they were back in the application server era.
So you can see some of our importations of we are using the test container frameworks here, right. And yeah, we're using the @containers annotation, and we've been discussing this, Oleg and I, and already we've discovered an improvement we can make in this application.
Yeah.
Which I'm excited to implement.
I will tell you about it again in a bit, but just to note, right? So we use annotations like test containers and @container. And just earlier today, we published a blog at the atomicjar.com blog about integration between test containers and JUnit, specifically JUnit 5. And in short, what those annotations do, they combine the lifecycle of the containers managed by test containers libraries with the lifecycle of JUnit tests. So you will not, in this test, you will not find the lifecycle methods on the containers. You will not find something that starts that Postgres container or that Liberty container, right? It's handled behind the scenes by the annotation, and it's just, as a developer, it's very convenient for you. You sort of declare this service that you need to use, and it's automatically kind of spin up for you. And you just need to control the isolation level. So here we have the container on static fields, which means that those will be spin up for once per class. So sort of similar to before all, and after all, they will be shut down and removed. Which is I think it's interesting. It's very friendly to developers, right?
It's just taking that abstraction layer up a bit, isn't it? Just making it easier for people to use this technology without having to worry about all of that.
Right. And then the tests themselves, if you scroll down, are those are the proper functional tests of the system.
Yes.
Right? So you create an API client, and then that client actually does HTTP requests to the systems, and then expects that data back.
Exactly. Yeah. So we're essentially testing the various different things that we should be able to do with this system, with this particular application. So as I mentioned, this is about collecting data from a system. So we're testing, can we add a system to that list, for example? Can we update a system, which we should be able to do? Can we remove a system? So fairly basic tests, but tests that prove that our application is working as we intended it to.
Yeah. I like personally, I like those sort of functional tests where it verifies the behavior of the system with a certain set of inputs.
Mm-hmm.
Right. So one advantage of those is that they will not break during a refactoring.
Yeah.
Right. Like you can very easily do whatever you want with the internals of the system, and then you know that as long as tests pass from the outside, the system sort of looks as it's supposed to be. Right. So I see the unit test annotations for test. JUnit annotation for tests. I see the container annotations from test containers for the environment setup. How do I run this thing?
So we are running this particular demo, and a lot of our apps actually run with Maven, but you can run it with Gradle if you want to. It's just up to you. We have a guide on Maven and Gradle. It's just we so happen to use Maven in our examples. So essentially what we're going to be doing is, because we're running in this particular VM that I've set up, I can't test the HTTPS stuff. So I can only test the HTTP stuff, which is actually the same in our cloud environment. So instead of doing the Maven verify that you see in this local hosted one, what I'm going to be using is the Maven verify with this particular edition, just so we're specifying that we're just testing the HTTP. So essentially what we're doing is a Maven verify, but just adding that in as well. So yeah, essentially I can just copy that, and I've already set up my VM ready here. So all I need to do is paste in my command, enter, and essentially what that's going to do is set off test containers to then run up the containers that I need for, so as we were saying, one for Liberty and one for Postgres. And then essentially we're going to start running our tests to be able to test that integration between them. And then hopefully what we should see at the end of it is 3 tests that are all successful. That's the aim.
Very good.
So yeah, you can just see, like, we're obviously printing this out so that we can follow what's happening as we go along. So you can see there we've started the Liberty container setup. So that's the next one. And we have 3 tests run and 0 failures. So we've been able to successfully run our tests using test containers in an environment that's as close to production as we can get.
That is spectacular. If you scroll the logs, actually, you don't even have to scroll. Look, you can see that in the logs, sometimes you can see the cool whale icon, which is, you know how some frameworks or some things pride themselves on having a giant banner in the logs. Test containers is subtle. It just gives you a little whale.
I love it.
Which stands for Docker, of course. So you can have the logs there, and the containers are being pulled if needed, and then the images are being pulled if needed, and then the containers are being run. I mean, what can I say? It's a great approach, right? What do I do if I don't have Docker?
Right. So, I mean, there are alternatives to Docker, right? So Podman is one example as an alternative to Docker. Like, you don't have to have Docker. A lot of cloud providers have their own alternatives. So it depends on who you have as a cloud provider as to what you could potentially use. But really, like, how we've set this up is specific to our application. So you could make this specific to your own application and change those commands to, instead of being Dockered, to be a different technology. This is the beauty of open source, right? Is that it's compatible with loads of different things.
Yeah. Yes. What I was looking, of course, I would phrase it that test containers tests are, of course, compatible with any Docker environment.
Yeah.
Right? It uses Docker API, and then I saw the test containers cloud icon there on your desktop. That's why I asked. Which is
exactly.
Test containers cloud is, of course, the product by Atomic Jar, sort of the serverless backend for running containers in the tests, which is cool. Can I show maybe a quick suggestion about the particular thing that
of course.
discovered?
Do you want me to go back to the code?
No, I can maybe I can share my screen maybe.
Yeah, go
instead
for
of yours. I overtook your screen, and this was just earlier, right? So this is the same test that I cloned from the repository, and you can see that it comes with even the tags for showing particular things in the learning environment there. So this is the real deal. And one thing that I noticed there is that we set our Postgres with the custom Docker image that we built earlier, right? So which it certainly would work, but it's a little bit less idiomatic than what one could get, right? So what you can do is you can go to your dependencies and add the Postgres module from the test containers ecosystem, right? And this is actually, like, there is a rich ecosystem of the modules, right? You can do all kinds of databases, relational databases, I don't know, document stores, Mongo, MySQL, Neo4j, all the technologies, everything that runs in a Docker, and then a bunch of non-database technologies as well, like Kafka and, I don't know, Red Panda, RabbitMQ, and so on. So what I just wanted to show is that here, instead of custom rolled out code like this, what we can do, and I'm going to send the pull request later. I just
please do.
I just didn't learn.
This is the beauty of open source collaboration, is you get to improve it all the time through other people. It's great.
So look, we can do public static and then Postgres container.
Yep.
Right. This is something that this is the abstraction that comes from that module that we imported in the POM. Right. And then we can just do literally the same. So we're going to say Postgres. We're going to call it the same. Right.
Yep.
And this is a new Postgres container. And we need to give it a Docker image name, which will be
Postgres image name
14.1. I know that it's 14.1 because that I peeked into the thing. And then we just need to configure that. So we do the same. We do with network because we had that, and we do with network alias. What was that? Postgres host, right? Because that's the network alias. And then I know that the Docker file there created the specific username and password for that Postgres. So I can do with username, admin, and then with password, admin pwd. And then we initialized, one thing that Docker image has is pre-baked schema in, right? So what we can do here, we copy the file to container. So we have our schema, which is the system data. It's a small but functional, right? So, and what we can do, we say just copy that file. So we take the class path resource, which is the string, right? Schema file, and then we copy it into a certain location, which is path in the container.
Yep.
Do you know the path by hand? Entry. Yes, initialization script. It depends on your particular Docker image, and for Postgres, that is that bit, right? And that's it, right? So this is now the same declaration as here. We need to add the container, but now we don't need to pre-build the custom Postgres image, and it will be configured as we want
using that module.
Using that module and using your API. So as a developer here, you have all the tools that you want to configure things at your fingertips, or if you prefer, at the fingertip that you click your mouse with. So yeah, I think it's just great. But in any case, the test will run the same. The test will run the same. It's just might
more
be a
efficient.
little bit easier. You don't need to worry about the Docker image built before and so on. Right. So that's a cool tidbit.
I can't wait to see your PR coming in.
Yeah. We will be like, whoever maintained that deep dive, here's the one benefit of Grace being on Task Container Live. By the way, so Kevin from the team says that whale in the log stands for the idiomatic animal used to ship containers through the ocean. So it's not just yes, there is a deeper meaning for the whale.
This is like, all I think when I think of that is like Finding Nemo when they travel inside the whale. Have you seen that? Yeah, oh, come on, you must have seen it. No, it's a classic.
Is it a sequel to Moby Dick?
No, it's a Disney cartoon.
Yeah. Okay. I'm gonna add this to my watch list. I'm sure it's spectacular.
Totally.
There's a clownfish, right?
Yes. Yeah. So you know some of it. Yeah.
Yeah. I recognize some small things. Right. Yeah. So this was a little bit of a short demo of how you can take your 15-factor application using OpenLiberty and create a few tests that you can run that will replicate and the setup that you have in production. Yep. And with Task containers, of course, you can, like, I can run it locally. You can run it locally. You can run it in VM. The CI, one of the very important team members is the CI pipeline. It can run it the same way. So yeah, pretty
cool.
Nice stuff. Thank you very much for coming. Do you have any questions? Oh, do you have any questions? Or are we only capable of doing the fun trivia information in the chat? Right. There are currently no questions. I'm sure that we will add the links to the deep dive and to the other information that Grace shared with us to the YouTube stream. So check the description below. And yeah, if you have any additional questions and you're not watching this live, but just on YouTube, please ping Grace. She goes by @Grace Jansen 27. On Twitter, or by Grace Jansen, no numbers on LinkedIn.
Yep.
So she'll be happy. I'm sure she'll be happy to chat about OpenLiberty or any cloud technologies.
Yeah, please reach out.
Thank you very much. I think this was a successful stream. thank you for coming, and I enjoyed this very, very much.
Thanks for having me. It was great to join.
Right, I'm gonna click the end stream.